Hello everyone and welcome to a new episode of Golang Cafe, and today we are going to talk about io.TeeReader. So in a couple of previous episodes we have talked about the io writer and io reader interface, which are the cornerstone of working with data with Go, and you will see them a lot in the Go standard library and a bit everywhere whenever you work with data, whether that's network data, that's files or memory. So the io reader and writer interface are the foundations of a lot of things that you will be working on, and the TeeReader is one of the helper functions that you can use to better work with Go and with data and with streams of data. The TeeReader is inspired by the T Unix command line, which we're going to see now, and its purpose is effectively to duplicate the input whenever we read the input. So it's kind of some sort of a multiplexer of data stream that is going to be used for different scenarios. We're going to go through one example today. We're going to see how we can use it. So the first thing we're going to do is gonna just check the doc for the io.TeeReader. The io.TeeReader it'll take a reader and a writer. So as we have said already, the reader and writer are a bit everywhere if you start to look around. And the TeeReader effectively duplicates all the data coming from reader into writer, and then it returns a reader with the data that is being firstly set into the original reader here that you pass in the TeeReader. So it's being inspired by the T command, which is a utility that copies data from the standard input to standard output and makes a copy of the data from makes the copy to 0 or more files. So you specify the number of files to which you want to copy the data, and this will go through each and every one of those files and will copy the input data into all of those files. So it's kind of a multiplexer, if you will, of data and a copier of data, the T utility. So let's just see how this can work. Input data, you can use a stream of data here, which is the just sending a stream of data. We use the pipe command in the Unix system, which you can use to send the data around. And then you can use the T command, from which then you can specify a set of files, and the data is going to be then copied into all those files in there. So the input data is taken exactly as it's coming in, and it's going to be copied into file 1 and all those files, and is also going to be copied into standard output. So let's see one example of this. So we can go through 1, 2, and 3.txt, and now we will see that the input data is coming out into standard output, but we can also see that the data is also being copied into the output files that we have specified in the T command. And that's the exact usage of the T command and the exact behavior as well. It's very similar behavior on how the TeeReader is going to be working within the Go standard library. The reader can be thought as a stream of data. As you can see here, it's very similar to what we're doing here. We're just passing a stream of data into T, which can be this one, stream of data into the reader. And the writer, the only difference is that instead of having a set of writers, you have just one. So you have just one writer here, although you could have more than one, because you can concatenate more writes by using multi-writer. So that will allows you to basically have a set of files, and then you will have a final writer which will duplicate all the contents. As you can see here, it says it creates a writer that duplicates his writes to all the provided writers, similar to the Unix T command. So those are effectively very similar to each other and very relevant to each other, the TeeReader and the multi-writer. But for the moment, we're just going to see the TeeReader by just copying the data into a single writer. So it's going to copy the data into a single writer, and it's going to return the data to the final reader. So the example of today is going to be an exercise where we attempt to download a fairly huge file. It's just a file coming from a Google free data set. It's about n-grams. It doesn't really matter what it is inside the file, because the objective of today is going to be around around the file download process and the way we use the TeeReader to effectively check how quickly and how the file is being copied over from the internet into our local file system. So the objective is as follows. The objective is to download the file. So we can write down the objective is to download the file, is to measure in real time the number of megabytes downloaded, and this should be updating each time we download new data, and then write the file into our local file system. So this is our objective. How do we do that? As you can see here, there are a couple of things. So you have to think about this like as a two writes. So it's like if the data, this one is the reader, is downloading the file, and then there are two writers. The first writing is gonna measure the progress. It's like a progress counter. It's effectively a progress counter. And the second writer is going to write the data into the file, and as the TeeReader command we could also have write the file into our archive or something, so we could have even three writers here. So this is some of the examples that we can go through. We're gonna go through that, and we're gonna use the TeeReader. So the TeeReader is gonna be set up in this way. So you're gonna have the response to the body as a writer, and then you're gonna have the counter as a writer. And the way that the TeeReader works is effectively, you get a new reader from the original reader that you get from the body. So this one is a R1. So R1 is going to be a file from the internet. Okay. Then you have counter, which is W1, which is progress counter. So the progress counter, what it does, it doesn't actually use the bytes, it just counts the number of bytes that it receives in the write method, and it prints out the number of total bytes written so far. So it's just a progress counter we're going to see in our console. The TeeReader, what it does, as you can see here, it takes R1, it takes W1 and returns R2. Each time R2.read is invoked, TeeReader, as we can see here, the implementation of TeeReader later, what TeeReader will do, will basically do R1.read, then it will do R1.write, and attempting to write the bytes read just from the read, and then will return. So this is what the TeeReader will do, effectively. So it's just encapsulating a read and a write together, and then returning the result. So then the R2.read is just unaware of the fact that we had just copied, sneaked the result into our writer, which is the counter here. We could also, we're gonna see now later on how we're gonna do the file downloading. But this is effectively how the TeeReader is implemented, and we can go and check that. We can go check that by just going into our local Go installation, and I think we have already we have the source code in here, so you can see the TeeReader implementation, which is just effectively what is like 4, 5, 6, 7, 8 lines of code. In fact, it's just a couple of lines. So you have a read method from the initial reader, and then a write. So it attempts to read from the initial reader, it attempts to write the data that's been already just read, and it just returns. This is effectively the TeeReader. So there is nothing complicated about the TeeReader. It's just that it's encapsulating a read and a write, and is then returning the result. So we can use that. The first thing that we're gonna do now is effectively attempt to download the file. So the objective is basically attempting to create a progress counter. So the first thing, we attempt to download the file using http.get. We handle the error, This is like a placeholder. You should not panic. You just handle the error properly. And then we need to remember that we need to close the response.body.close. The response.body we need to close using the fur keyword at the end of the main or whenever the function exits. And now we know that the response.body, HTTP response.body, it's an IO read closer, and an IO read closer it's an IO reader. So an IO read closer implements an IO reader, so we can actually use that in our TeeReader. But the first thing that we're going to do now, before using the TeeReader, we are going to, as we said, we want to download the file. So download the file into our local file system. So we declare a local file. We do os.open. We call it download 5gram.txt, which is the file original file name here. Then we do os.ocreate, which is the flag for creating the file if it does not exist, and then o the write only, which is just opening the file in write only mode. We handle the error. Obviously, you should handle the error properly. And we defer local.close as well, because we don't want to leak to have the file opened. Now, copy rs.body into local, which is effectively copying the 5 bytes that we are getting from the internet into our local file system. How do we do that? Well, effectively, if you remember one of the previous episodes where we've seen how to read the data from a reader and how to write data into a writer, what you can do, you can just do res.body.read and you read the data, and then you check if the error is equal to EOF. So there's a lot of boilerplate code here we are going to skip right now. And we are going to skip because we can use an helper function which is called io.copy, which is in the Go standard library. And the io.copy function allows us to do what we have been doing in the previous episodes, where we're just going through the reader and we are calling the read method each time until we reach the end of the reader, until we reach the end of the file in this case. So the io.copy is attempting to copy all the data coming from the reader into the writer that you have specified as destination here, and it's going to stop only when we reach the end of file or when we reach any errors. And those are the only times where it stops. So it stops effectively only when we arrive at the end of the file, or if we go any errors. Any returns the written number of bytes successfully. So it's a very handy function, and it uses a buffer of 32 kilobytes. So if you wonder each time that it copies the data into the writer, what's the size of the buffer that is going to be used, then that's going to be 32 kilobytes. And you can see that in the USR local bin as well, local go source. Obviously, this location will vary based on your installation, your operating system, and all of that. You can check the go root environment variable to see where that is set up. So the IO copy. So the copy buffer. So the IO copy, as you can see here in the implementation, it's called the copy buffer in the underline standard library, and it's taking a writer and a reader, and it's taking also a buffer, which in this case is null, is nil. So you can also copy passing a specific buffer. So if you want to have your own buffer, you can do that. But in our case, what happens is that the buffer is going to be nil, and so the buffer here, line 397, the buffer is going to be nil, and the size is going to be initialized to 32 kilobytes, as you can see here. So that's the implementation of the IO copy, which is just a for loop where it attempts to read the data from the reader and then write the data into the writer. But we can it can save us a lot of time by just using the IO copy, because we don't have to then to implement everything from scratch. Whoop! I just res.body. panic. So the effectively now we got 14 lines. What happens with these 14 lines is that we are downloading a file and we are just writing the file into our local file system. That's all. That's everything we're doing. But we're not measuring the progress of the download. So we want to do that. And as we said, what we want to do, we want to declare a TeeReader. And the TeeReader takes a reader as an input, which is the response to the body, and takes a writer, which is the counter in our case. So we're going to define a counter. So the counter is a struct, and it needs to implement the io writer. So the io writer has the write method. So counter has a write method which takes a byte slice. Takes a byte slice and returns an integer and an error, where the integer is the number of successfully written bytes and the error is any error that's occurred. So the counter, what it does, it just keeps track of the bytes seen so far, the bytes written so far, and we can just do that by setting up the uint64. Obviously, we are talking about bytes, we are talking that it's 200 megabytes file, so just want to make sure that we don't overflow with the standard integer. And so we do c.total plus equal the length of the buffer. So we know that b, and again, now we know that we're using the io.copy, so we know that the buffer length is 32 kilobytes. So we're gonna see 32 kilobytes at a time, effectively. But that depends on the way that you call the read and the write into the counter, into the reader. So if you had a bigger buffer, you could see many more kilobytes. So that depends on the implementation, effectively, of your copy. Now we're using a standard implementation, so that's the standard buffer size. And then we want to print the progress. So how do we do that? We do fmt famt, and then we downloading. So downloading, now we can set the megabytes and progress. So we just need to calculate progress. So we know that progress is as a float, and then we have the total divided by 1024. So we have bytes in here. Bytes we convert to kilobytes, and then we multiply by 1024 and we convert to megabytes, just to have a proper scale. And the number of bytes is just ln of b, and the error is nil. And that's our counter. That's it. It's basically 1, 2, 3, 4 lines of code to keep track on how many bytes, how many megabytes in this case we are writing. And the TeeReader will ensure that each time the copy will call read from the here we need to change effectively to change R2, which is the TeeReader. So just do something like that. It's easier to read. Rest of body, and then we have our counter here. So now the TeeReader returns a reader, and each time we read from this reader, we're going to copy the data from body, response to body. We are going to write into counter, so this process is triggered, and we're gonna see the famt printf, and then it's gonna copy the data into local, which is our local file. So I think this is pretty much all that we need. This is everything we need. So now we attempt to run the TeeReader, and we also have to convert the types, and the line 44 was to open, it's open file, so you also have to properly, this one is open file, and here we need to convert the integer into sorry, this is one as a uint is int32 is should be uint64, so we just counting properly. Okay, so it's quite slow, but this effectively what it does, it just as you can see now, it's each time the io.copy reads the data from the response.body. In reality, it's reading the data from the TeeReader reader. Each time we're reading the data from the TeeReader, the counter.write method is invoked, and when the counter.write method is invoked, we are printing the downloading and the number of bytes read so far. And as you can see, the rate is quite constant. As you can see, there is no particular spike, and the only rate, obviously, the rate is depending on the network speed, which is quite slow now. But the rate is quite constant, and it's because the buffer size is always 32 kilobytes. So you see increments of 32 kilobytes. And now we can see our file content, which is download 5gram.txt. And the file is gzip compressed. So the issue with the gzip compression is that it doesn't get decompressed automatically. So it's obviously a gzip file, but the inner content is a CSV, so we need to decompress it. And we can do that by just using compress.gzip new reader, which return a gzip reader. And the gzip reader, so how do we decompress that? Well, we can use the gzip reader, and the reader is an IO reader that can be read to retrieve uncompressed data from a gzip format compressed file. So effectively, we can initialize a gzip reader using our compressed data, which is coming from the response.body. And whenever we call the read method from this new reader that we are creating, the data will be automatically decompressed. So this is one of the way that we can compose different components of the Go standard library using the reader and writer interface together, because it's very handy for us now to just decompress the data. So a way we can do that, we go into the response.body, and we decompress with just the cdec. And we set the gzip new reader, which will decompress automatically, response.body. So we just need to check for the error here, which is coming from the new reader here. And we replace response.body with the decompressed reader. And we also need to import the package compress gzip, and then we run the same thing again. As you can see now, it seems much quicker. The difference is that now, instead of counting the compressed megabytes, it's counting the decompressed megabytes. So it's downloading the data at the same rate. The only difference is that whenever it's once the data is on the machine, it's forwarding, it's decompressing the data first, and then it's counting the data. So it's not counting the data before it gets decompressed, and that's why the rate now it's much quicker. So effectively this, as you see, is 328 megabytes. Now we can see the contents, if that's what we expect. As you can see now, everything is what we expect. And that's how you use the TeeReader. So the TeeReader allows you to effectively copy a stream of data into a writer, as you can see here, and into a writer allows you to copy the data into a writer, and that's how you can use it. So, and if we wanted to discard, for example, if you wanted to discard the local file, if we didn't want to discard the file, if we didn't want to save the file, we just wanted to measure the progress, which I don't know if it's a useful use case. We could do something like io.util and discard, and this what it does. We can check the docs. io.util discard. It's a writer, and this writer basically whenever all the writes call happen, it will not do anything, so it will not write any data. And we can use that just basically to read how many megabytes the file is, or to get the progress of the download. So, but the file is now being discarded, it's not being written. This is just some of the useful functions. So some of the useful functions we've seen today are the TeeReader. So the TeeReader is very useful because it allows you to copy the data into a writer whenever you read the data. The io.TeeReader, which is like a dev null way of discarding the data, where you can discard the data. And those are the main functions. The io copy as well, which is used to copy everything from a reader into a writer, and we also see in the gzip new reader, which is used to decompress the data. So as you can see, we're working a lot with the reader and writers, and we are composing together all the readers and writers together to have different results, but in a very expressive way. So that's how you can use readers and writers in Go in order to work more effectively with your Go code. So that was everything for today. Thanks for watching. See you at the next one.